Welcome again to another session where we are going to talk about quantitative reasoning. Quantitative reasoning. I'm sure we're familiar with the concept of quantitative reasoning. As the name says, it's all about reasoning, using your mental foresight to reason accumulatively what has been given, the quantity of what has been given to you. In our quantitative reasoning today, we will be talking about a few things, actually 3 different segments of quantitative reasoning. Now, this is more of allocation. This is the quantitative reasoning on allocation. They say in a school, some students offer economics, French, and government. Now, if the circular path represents those who offer economics, the triangular graphics there represent those who offer French, and the rectangular design there represent those who offer government, as shown below. You can see the given digit or the teaching figures, the given figures allocated to all 3 of these subjects. The question they're asking is, how many students offer both economics and government? How many students offer both economics and government? Probably most of us, we tend to limit our thinking or go beyond the scope of what is given to us, and we think bigger. What do I mean? If you're given, or if you're asked a question and there is no direct specifics to it, friends, just go ahead and give the answer as it is in the designated column. So what do I mean by designated column? Take for example economics. In economics there you see where it is written 8. And in that 8, no other figure like this triangle or the rectangle are connected to that particular 8. It means that 8 inside the circle or inside that path, that 8 is designated to only economic students, only students that offer economics. Furthermore, you look down, you see a place designated for 5. Now that 5, you can see the rectangular, the triangular and the circular figures are engaged with that 5. They all meet at that 5. But the rectangular is still outside that 5. The place where the triangle and the circular meets, the triangle and the circle meets, not the rectangle, is designated to those who offer economics and French. Going further, you can see the place designated 10. And it's only found in those that offer or is found in the figure, the triangular shape, which means those that take only French, no other subject, not economics, not government. You can also look down and you see 7. Now 7 is given to those, because 7 is found in the rectangular shape, but not found in the triangle, it's not found in the circle. It means 7 is for those who offer only government. Now you see 2. 2 is designated with the triangle and the rectangle, meaning there is no circular with it. Hence, 2 is for those who offer government and French. You see 6. 6 is for those, or is given to the figures circle and rectangle. So the rectangular and the circular path or the shapes have the figure 6, meaning is designated for those who offer economics and government. Finally, the figure 4 is allocated to the central point. All the figures are related with 4. The triangular is there, the circular is there, the rectangular is there. This means that is for those people who offer all 3 subjects, French, economics, and government. That being said, or that being clarified, if you look further, you'll see number 1 question. They ask, how many students offer both economics and government? You just run through to your figure shape, or your shape rather, where you have taken down all your designated points. If you look at government and you look at economics, you find that it's 6 that is in that place. When it comes to the place where they intersect, the circle and the rectangle. Circle is for economics, rectangle is for government. Where the meet is the point 6. So your answer there is 6. Nothing more, nothing less. Second question, they ask how many students offer all 3 subjects? All 3 subjects. This is one of the most tricky questions that students find hard to navigate. Students usually go forth and give a grand total of all the accredited subjects, which is wrong. When they ask all 3 subjects, you focus at the midpoint, the midway, the middle. People, there's 3 subjects. Where do they meet? Where do all 3 subjects representing circle, triangle, and rectangle, where do they all meet? They meet at the point 4, the place that is designated with number 4. It then means all 3, those who offer all 3 subjects are 4 persons or 4 students. Then the number 3 question, they ask how many students offer only. Now here's the catch. There is a specific notion on that. They say only French. Now I will tell you, going further, I will still highlight some other questions that are not here. I will just highlight it for the purpose of understanding and for the benefit of hindsight. Now, they say only French means those that take all part of French without taking economics or without taking part of government. And if you look at your structure or your figure, you find out that number 10 is designated to the triangle, and because French as a subject is given the figure triangle, the triangular figure. Hence, 10 is your answer there. Number four question, they ask, how many students are there altogether? What they are asking you here is the total number of everybody. What you should have done, or what you might have made mistake when they ask you how many students offer all 3 subjects, the mistakes you have made. When you go to put everybody there, the sum total of everybody there. Now, this number 4 is where you do that. You add the 7 plus the 5, the 8 gives you 15. The 15 plus the 6 gives you 21. 21 plus the 5 gives you 26. 26 plus the 4 gives you 30. 30 plus the 10 gives you 40. 40 plus the 2 gives you 42. So how many students are there altogether? There are 42 students altogether. Then they ask how many students offer economics. Now, here is the catch. They didn't ask for economics only. They asked for economics. They didn't ask for economics only. They asked for economics. So you look at the figure that represents economics, which is a circular figure. Every digit or every number that is allocated to that circular figure, whether they intercept with other figures, other shapes, like the triangle or the rectangle, whether they intersect, whether they meet together, it doesn't matter. As long as they are taking economics, those are the people you're taking cognizance of. Those are the people you're taking interest in. So you're taking the 8, the 6, the 4, and the 5. Those are the people that falls under the circular part, which is economics. And by the time you add the 8 with the 6, you get 14. You add 14 with the 4, you get 18. 18 with the 5, you get 23. It then means 23 students offer economics. Again, one more time, the difference here is the only. In the case study of number 3, you see they say students offer only French. Or sometimes they might put it, or sometimes they might just confuse you by putting it, offer French only. It's the same thing. Only French or French only is all semantics, is all the same thing. That means you are looking for those who are doing just one subject, French. But when they say offer economics, they did not put only. You're looking at everybody, even those that are attaching themselves with 2 subjects. Some of them are doing 3 subjects. One of them is economics. As long as they are doing economics too, you put them together. And thus, your answer becomes 6 for number 1, 4 for number 2, 10 for number 3, 42 for number 4, and then 23 for number 5. So again, let me recap again. The key word there is, or the differentiating word there is only. Please know how to sort out the word only so you don't make mistakes. Another one you might find confusing will be the case study of 2 and 4. All 3 subjects are there all together. Please know how to differentiate them very well. Now let's enter to another problem in quantitative reasoning. Now you have been given a sample. They say 4 bracket 3 bracket close 2 is equal to 12 divided by 6. And they're saying the answer is 2, because if you do 12 divided by 6, you're going to get 2. They're asking, how did they get this? This is how you flow. The one in the middle is working with the one from the right, from the left hand. From the middle, the one from the left hand will be up. So the middle with times with the one from the left hand to become in mathematics we call this the numerator. The fraction that is upstairs is called the numerator. Then the middle man will times with the man at the right to form the denominator. What do I mean? 3 times 4 or 4 times 3 will give you 12. 3 times 2 or 2 times 3 will give you 6. Hence, 12 divided by 6 gives you 2. Let's take the second, as you can see on your screen, the second example. You have 8, you have 5, you have 4, and they say 40 divided by 20, and they say the answer is T2. Again, your position should be the man in the middle. The man at the middle times with the man from the left will form the numerator. The higher number, the number on the top, is 40. The man in the middle times with the number at the right will form the number at bottom. The denominator will be 20, because 5 times 8 is 40 and 5 times 4 is 20. Hence, you do 40 divided by 20 will give you 2. Then, let's take a third example. You have 10, you have 2, you have 2, and they say the answer is 20 over 4. How did they get this answer? It's simple. Okay, now the answer is 5 here. After you divide. Middle 2 multiplied by the left-hand side, 10, you give it 20. Middle 2 multiplied by the right-hand side, 2 will give you 4. 20 divided by 4 is 2. It's rather 5, rather, sorry, pardon. 20 divided by 4 is 5. Now, you're given a set of numbers there. Just use the same pattern, the same procedure. Solve all the questions that are given in the slated exercise. Now, let's go to the next sample there. After the first 5 there. If you look downward, you will see a sample there. And this is from where we will get some questions from our past questions to answer, because some questions are related to this particular question. So pay attention very nicely and very neatly. Watch this. They say 4, an arrow going up, and they say 3 gives you 12. Note this. And they say 16, an arrow going down, is a different number, gives you 4. Note this. All the arrows facing up denotes multiplication. Bless me. Then all the arrows facing down denotes division. So whenever you see a question that has the arrowhead facing up, pointing up, this is what's called the arrowhead. And this is what's called the arrowhead. Whenever you see a question that has the arrowhead pointing up in this scenario, you have to multiply. But when the arrowhead is pointing downward, you have to divide. Let's take the case study of number 1 in the exercise there. Let me do that number 1. Then you will do the remaining 4. You are told you're given a box and they put a question mark, means you're looking for that one. And they put an arrowhead coming down and they put a 4. And they say the answer is 16. What they're trying to ask you is what number amongst the options given to you, and they give you options A, 16, B, 62, C, 64, and D, 56. They're asking you what number can divide with 4 because the arrowhead is pointing down, and we know from here the arrowhead facing downward is division. So they ask you what number can divide with 4 to give you 16. So you can either try it one by one, try each number one by one to get try each options one by one to get the particular or the correct option, or you can use from your understanding to do it. I love to use a different means. Whilst I already know the answer, I love to treat this like algebra question. What do I mean by algebra? Look here. This is an unknown variable, right? We don't know this guy. And they say, let's call him x divided by 4. So I have made everybody here an algebraic format equal to 16. And in algebra, I know that this can also be represented as this, x over 4 equal to 16. Look carefully. Can you see I can do cross multiply now? So you have to cross multiply. Just in case you cannot think that way, you want to do, if the dividing each options by 4, one by one, is too tedious or too long for you, you can use this method, this procedure. So if I cross multiply now, I'll find out that I have x equal to 16 times 4, which is equal to 64. So now I have gotten the unknown here to be 64. What option is showing that it's 64? The answer is option C, 64. Hence my answer is 64. So you can either use the direct method or 16, dividing each option by 4 to get the answer. As the case may be, it's not like that for all the questions. There are some of them the arrows will be pointing up. You can either use this procedure for the direct procedure of dividing each of the options by 4 to get the answer, or you can use the algebraic unknown variable method to solve this problem. That means you have to be good with your algebra. See why you need mathematics in your life. So that's how you solve this problem. I believe that you'll be able to navigate the other questions, even if they look a bit tedious, a bit hard, but indeed they are really, really simple. If you just put your head to either using the direct method or the indirect method. Direct method from the sample, or the indirect method. So with that, we have come to the end. And before we end, let's take some questions from our past questions to see more about, let's answer some questions from our past question to understand what we are trying to achieve here. Now I'm taking my question from year 2013. Sorry, year 2020. Question: quantitative reasoning and vocational studies or aptitude, from question number 13, 14, 15, 16, and 17. Now, in question number, I can wipe this now. Now, related to what we just did this last our last case scenario, they gave if you look at your screen very well, you see they gave this sample. They gave they gave us this threshold. They said A, an arrow pointing down, B is equal to, sorry, the question to go up, okay, sorry. They gave us this sample, sorry. A, an arrow pointing up, B is equal to A squared plus B squared. So follow the threshold they're giving you, follow the sample they are giving you, follow the procedure they're giving you. This is how you find it. In the previous case, arrow pointing up was multiplication. But here the arrow pointing up is addition. But both sides of the numbers are to be squared. The A is to be squared, the B is to be squared. Note that. This is our first case. Second case, A, arrow pointing down, B is equal to A squared minus B squared. Again, the previous one we did, we had the division. But here, the division for the arrow pointing down. But here we're having the subtraction for the arrow pointing down with the both sides squared. And then we have the final case scenario where they say where you have A and you have bracket B, something up, B, arrow down, B, bracket close. Sorry, the arrow here is pointing up. You have an arrow here pointing up. You have A, B, arrow pointing down is equal to, and they say the answer will be A squared. Why did they say it's A squared? What they meant is B minus B will be 0. B minus B, which is when what you see here now is like applying your board mass. It's like saying A plus bracket B minus B, A squared. And we already know from board mass that you work with your bracket first. And if you do B minus B, any value that is there, if it's the same value, B minus B means the same value. And if they are the same value, the answer will be 0. 0, A squared plus 0, anything plus 0 is that same number. Hence, the answer is A squared. Now let's answer some questions. They said, the number one here, they said we should find 4 they describe this for us. Already we know that any arrow pointing up is addition, right? Of course, it's addition. So we have 4 plus 5, hence. But one more thing is remaining. They say whenever it's pointing up, this is addition, but this size must be squared. So 4 squared plus 5 squared. This means 4 squared is 16, plus 5 squared is 25, hence your answer is 41. Your answer in that here is E, 41. Let's see another question from the same year. Another question says we should work with 20. Now this time the arrow is down, 10. The presence of the arrow down tells you is minus, subtraction, minus 10. But again, both sides, we already agreed, must be squared. So use 20 squared minus 10 squared. We know that 20 squared will give us like saying 20 times 20. Let's do it slowly so you can see. So we understand. 0 times 0, 0, 0 times 2, 0, 0 times 2 times 0, 0, 2 times 2, 4. So 20 squared will give us 400. Minus 100 squared. Okay, let's do it so we can know. 0 times 0, 0, 0 times 1, 0, 0, 1 times 0, 0, 1 times 1 is 1. 10 squared will give us 100. 400 minus 100, your answer now is 300. Hence, your answer from that year at that particular question, number 14, is 300D. Now let's see a more tricky or more trickier question where we are dealing with fractions. The question 15 talks about a fraction here. Now we are having a fraction 1 over 2. Let me erase this right now. So 1 over 2. We have an arrow up. Bracket 1 over 4 minus 1 over 4. Now, the question is, do we remember this question? Of course we do. Is under the third case study or the third sample given to us, where they say A bracket B minus B is equal to A squared. Can you see minus 4, 1 over 4, and 1 over 4 minus 1 over 4 will be 0, naturally, because they are giving you. Now, but in the likelihood, or rather, sorry, before they put it this way, which means 1 over 4 plus bracket 1 over 2 plus bracket 1 over 4 minus 1 over 4. All right? But in the likelihood, this will not always be the case. There's a likelihood that one of these numbers might not be the same. That case, you must do the proper calculation. You cannot assume it's 0. Why is this one 0? Let me show you why it's 0. 1 over 4 minus 1 over 4, using mathematical means. We know that the multiple, common distance is here, 4. 4 into this is 1, 1 times this is 1, minus 4 into this is 1, 1 times this is 1. Hence, you have 1 minus 1 is 0 over 4. Anything divided by 0 will be 0. That's why whenever you have two numbers of the same, minusing each other, subtracting each other, the answer is 0. So thus the answer here will be, but we know this guy over here, half, must be squared. So what is half squared? Say half times half, that's half squared. Your answer is equal to 1 over 4. And thus, your answer for that particular question in 2020 is 1 over 4C. How about if you are given a question now where there are two different, inside the bracket there are two different numbers represented, not the same numbers. Now let's see that in number 16 of that same year. You're given a question like this. And they are asking you to find the answer. Now, can you see inside the bracket what I said earlier on? Inside the bracket, there are two different figures represented there. That's to say, this becomes 8 plus. The symbol of this is plus, bracket, 6 minus 5, bracket close. But of course, we know, oh, by the way, everybody inside here is actually squared. Everybody is actually squared. We know that the square root will play a part. So 8 will become 8 squared. Pay attention carefully. Plus 6 will become 6 squared minus 5 squared, bracket close. Everybody in the bracket is being squared. It becomes 64 plus 36 minus 25. And then it becomes 64 plus 11. 36 minus 25 will give us 11, which means 36 minus 25. 6 minus 5, we get 1. 3 minus 2, we have 1. Thus, your answer will become now, or rather, the representation will become 64 plus your brackets. What you got for your brackets was 11. And if you add 64 plus 11, you have 5 and you have 7. Your answer now, your final answer is 75. Meaning, your answer for that particular year, question number 16, the answer is E, which is 75. Now, we are now at the last point in this particular session, which is working with decimal number. We've already worked with whole numbers. We've worked with fraction number. We've worked with bracketed numbers. Now we want to see what will happen when we work with decimal numbers. Stay with me because this is the interesting part of this social. This one is going to test your brain and it's going to move your quantitative, your reasoning to the next level. Now let's erase this whole thing. You're given, in that here, you are given a question. They say 1.3 and they drew an arrow down signifying minus or subtraction. First things first, let me teach you something to do first. And this is how I usually teach people how to deal with questions that have to do with decimal points. You're given 1.3. Let's treat them one by one. Let me cover this path to focus on the 1.3 here. You're given 1.3. And 1.3 can be written as, if you count 1 like this to eliminate the decimal point, you have 13 over 10. Similarly, 0.7. If you count 1 to eliminate the 0, you have 7 over 10. So what they're asking you here to do is to do 13 over 10 minus 7 over 10. You've now made everything to become, decimal place, decimal points, or rather fraction. You converted from fraction to decimal. You'll find it a lot easier to work with fraction. But here's the catch. Everything must be squared. Everything is actually squared. So we're doing everybody squared, everybody squared. Now what is 13 squared? 13 squared by our times table, you can see 13 times 13 will become 3. This is 3 and this is 1. The answer should be 169. So 13 is 169. Why 10 squared is 100 minus 7 squared. 7 times 7 we know is 49. 10 squared again 100. We'll now look for our factor. The guy that can factor, who can go with our friends at the bottom, the denominators. 100 divided by 100 will be 1. We have 169 over here minus 100 divided by 100 will be 1. We have 49 over here. Now you might ask the question, why are we working with minus sign? Why not addition? Or rather, why not addition rather? Is because the arrowhead is facing down, thus is minus sign. If you do 169 minus 49, you have 0, you have 2, you have 1. You have 120 all over 100. Remember, you eliminated your decimal point earlier on. Now let's introduce our decimal points back into the fold. If you cancel 1 0 here, you will cancel this 0 here. Or better yet, you can still leave the 0. From every 0 you cancel, you're moving your decimal point inside. So cancel 1 0, you move your decimal points, it becomes 12.0. Then they cancel the second 0, it moves 1, and it becomes, your answer now is 1.20 as the point where you, as the difference between 1.3 and 0.7. The difference between 1.3 and 0.7 is 1.20. And now, if you notice now, this is the final answer, but there's a different way, another way you can do this. If you don't like the method of making this a fraction, I call it elimination of decimal points. So from this top, let me do this one over here. I'll do this one over here. From this top, I'll eliminate the decimal point. I have 13. I eliminate the second decimal point. I have 7. Now let me put the 2 decimal points over here and make it a smiley. I call it the smiley face theory. Put the 2 dots. Can you see the 2 decimal points? I put a smiley face and I leave him here. I know I have 2 decimal points. to put back. Let me work with this now. 13 squared and 7 squared. We are minusing both of them. 13 squared we know is 169. 7 squared we know is 49. And when you do 169 minus 49, you get 120. Don't forget you have your smiley face. 2 dots, 2 decimal points taken. Count in. 1, 2. You've gotten back your decimal point. Your answer now is 1.20. So whichever method you want to use, it will give you the exact same question. And I believe with that, we've come to the end of today's session or dealing with numbers in quantitative reasoning. Thanks. See you next time.